Right, so one. Okay. Any questions on yesterday's topic, like connecting the flat file to the BODS system? And so any questions in connecting to the BODS system?
Oh, yes, I
Hello?
will. Just 2 minutes.
Yeah, Prakash, is somebody joining?
Just 2 minutes. Just 2 minutes.
Okay.
Just 2 minutes. So, Jairam join అవుతున్నారు.
Okay, okay. Right.
Just 2 minutes.
Hello?
Hello. Yeah.
All right, I
Let's
think,
start.
yeah,
Yeah.
I think everybody is there. So we'll do the start now. Okay, now I'm muting you all, and just before I mute you all, if you have any questions on yesterday's class, please feel free to ask me now. or you can also email to me at bevo.dataservices@gmail.com. I repeat, bevo.dataservices@gmail.com. You can send me an email on that. And a quick recap on yesterday. So we were checking about the different ways that we have been extracting the data, like what are the different options that we can connect a flat file to the BODS system, and what are the different precautionary measures that we need to take, or what are the different mandatory steps that we need to take when we are extracting the data from a flat file. And we have seen one scenario where we extracted the data from a flat file and loaded it into the target system. So on top of that, we will look at the different scenarios, like we will see one assignment where we will be extracting the data from a flat file and loading it back into a flat file, and I'll tell you when and how we will get such scenarios. And the second one is we will extract the data from one database table and load it into another database table. That is what I'm mentioning in the screen, SQL to SQL extraction, and SQL to flat file extraction, and flat file to SQL. We have already performed that. We will also connect to the SAP system, and we'll extract some few tables from SAP, and we will try to do some conditional scripts and global variables on top of that. Okay, so we'll be looking at these things. And yesterday we just covered how do we do a fresh extract from flat file and load it into the database table. Today we'll be looking much more into a little more technical into that. So let us go back to the designer. I think I have to log off and log in once again. So just give me a second. So I have created some sample load files on my desktop. Okay, so I have some source flat files which I have created manually. So we'll be using those flat files as our sources, and we will try to create some database tables, and we will see all the scenarios that were prescribed for today. So let us log into the Business Objects Data Services. Alright, so you remember this is the server name, this is the user one, is the user that we have created, and we are logging through the SQL authentication with a username and password. So I told you about this today. If you are continuing, you may corrupt the repositories. Why will we get this message? This message comes because if the previous time that you logged in and logged out was not proper, so if your logout was not proper, it says that still the user 462 is still logged into the system, and again somebody is trying to log into the same repository. So that time, if you just click on continue, it will whatever the previous changes that this particular user has done will be lost. So you just go for a reset user. So reset user will reset the user from the old user to the new user, and here we go. We have created our first job yesterday, extracting the data from a flat file and loading it into a database table. And in fact, Rishabh had a question yesterday asking if we can load it into two different tables. Yes, we can. We have done that as well. And today we'll be looking at scenarios. So just let me open a notepad. Okay, today we will be looking at scenarios like SQL to SQL extractions and SQL to flat file extractions. Then third one is a flat file to flat file extraction, and fourth one is SAP extraction. We have a question here. Rishabh, can you hear? Can you hear me now, Rishabh? Can you confirm? Just give us a second, guys. All right. So sorry, I just saw your message. Thank you. Okay, so please let me know if there is any technical problems, like if my screen refreshes a little slow, or is there a problem with my voice, or is when my voice and accent not clear. Do let me know. All right, so we'll be looking at these scenarios today, and I think this will be good for 1 hour. So first one is SQL to SQL extraction. So when and how we might be using these kind of scenarios. So if you take a real-time scenarios, so there will be clients who will be working on 2005 server, SQL server, and he wants to upgrade to 2008 SQL server. So if it is just an upgrade from 2005 to 2008 SQL server, probably he might be having his best software, in-house softwares which can do that migration. But those in-house software can only do a migration, but they cannot apply the transformation on the data. So if you apply a transformation on the data, then probably you'll be losing the original copy of the data. So either you have to do it on the source system, or you have to do it on the target system. So in order to do the migration in a separate way, and in order to handle the data in a good way, so we need to utilize the BODS in between them as a migration tool, because if you go and follow the in-house softwares or in-house procedures within the SQL, so probably you might not get an opportunity to perform the transformation on the data. And if you perform the transformation on the data, they will override the source data with the converted values. So we don't want to do that. And on top of that, if, for example, let us take a second scenario that the customer is having SQL Server as a backend database, and he wants to move to Oracle as his backend database. So in these scenarios, you must be doing this kind of extraction, SQL to SQL extraction. So we just need to create the data stores to connect to our source system, target system, and after that we just are pretty good. I mean, every database has the same type of connectivities. So now for the SQL to SQL extraction, let us see what are the different steps that we have to do. So A, create a data store and connect to the source database. Then the second one is import the tables that you need to perform the job. So what are the source tables? Because once you establish a connection to the source database, you will not be able to see the data already reflecting on the data services side. You have to identify what tables you are trying to extract, and you have to establish a connection between the BOD system and the source database, and you have to import these tables. And once the tables are imported, you have to build your job. And fourth step is execute. Because we already, I'm not mentioning about the target database here, because we already created the target database, and what are the table that we'll be loading? We'll be loading it into the target data store. So now we will look how to create a source data store and how we are going to import the tables. So the process of creating a data store on top of database is almost the same, even though if it is an Oracle or a SQL or a DB2. So whatever the database it is, so the process of creating that the data store is same. So now first step, let us create a data store. let us create a data store and connect that to the source database. So first we need to understand on which database are we going to create, which database is going to act as our source. So I have downloaded some sample databases from internet, which is Northwind, and the second one is AdventureWorks. So both these database tables has some pre-built tables and with data in them. So if you look at this data, so you have almost a real-time data present here. So which, I mean, these two are AdventureWorks and Northwinds are the first Microsoft project. So they have original data that is related to the project. So you can utilize these tables just in case if you are running out of any source data. You can download these tables and download these databases, and you can attach these databases to the SQL, and you can utilize them as your source databases. So now let us take Northwind as our source database, and we will build a data store on top of that. Okay, so now go to the data store. Sorry, one second. So go to the local object library of your designer, go to the data store tab, and as I told you yesterday, there are different ways in which we can create a data store. First one is go to your start page and you can click on this shortcut icon here, or you can go to the project, go to new, and go to a data store option here. You can create a data store with this navigation, project, new, and data store. And the third option that you get here is go to the local object library, and within the data stores tab, right click and go for a new data store. Okay, so here the naming convention, please remember ds underscore source is the data store name, or you can mention also as Northwind because we know the name of the database. And the data store type is a database. So the database type is the SQL Server, and the database version is 2008. And the database server name, we need to copy that from the server here. Okay, and the database name is Northwind. And the username and password, you need to give all these credentials and click on apply to see if all the credentials are good. If there is any problem with the credentials that we give, once you click on apply, it will throw an error. So then you need to understand that some of the credentials that we have given are wrong. So if it is not throwing any error, once you click on apply, you click on OK. And now your source data store is created. Now the second step is identify the tables which you are trying to build a job on and import those tables into the designer. So first we need to go to the database, expand the tables of the Northwind, and we will see what are the different tables that we need, that we are trying to take. So let us take the two tables, orders and order details. Orders and order details. So orders in real-time scenario is like when you place an order, purchase order, the POs will be generated, and these POs will be tracked in the orders table with a particular order ID, because there will be a life period for a particular order, because an order cannot be active for quite a long time. So we have an incoming question here. What is the option enable CDC? So yeah, so that is CDC stands for change data capture, and we'll be looking at that in more details a little later. Okay, enable CDC when your source database is capable of handling the change data capture. So at that time you'll have this automatically enabled. So on top of this, which you will be creating the jobs, and once you have any CDCs activated, change data captures activated on your source, the source table will be added with one extra column, and that column will have the operands like insert, I for insert, U for update, D for delete, and B for before update. So these kind of operands will reflect in front of each and every row, and these operands will act on that particular respective row where they are present. So with that, they will try to either insert the data into the target table or update the data. It says that this record is an updated record, this record is a deleted record, this record is an inserted record. So these change data captures are coming from the database, and if your database support that, then the OVS can also support that. We'll look at them later when we are going with the transformations like integrated transformations, where we will be looking at multiple CDC options. We'll be looking at that at the time. Okay, so now we have two tables. We have identified two tables, orders and order detail. Just give me a second, I will have some water. All right, so yeah, sorry, my throat is troubling me. So with that, we identified two tables. One is your source table and two source tables, orders and order details. So we will be calling these tables into the designer. So how do we call some tables from your databases, source database, to the designer? So this is one of the most important thing when you are working with the database as your source in some projects. So you'll have a requirement saying that, okay, these are my source tables. You have to connect these source tables and extract the data from them. So the functional owner who writes the functional specs, so he will mention the name of these tables in his functional specs, and you just need to create a data store in which directly connects to your source database. Or even in some big projects, you are not allowed to create these data stores. The administrators, so they will have an option to create all these data stores and upload them into the central repository, and so that you can download these data stores. So we will look at more details of the admin roles and creating the central repositories in tomorrow's class. Okay, so they will create these data stores and upload them into the central repository, and we local users, everybody configure or everybody connect to the same central repository, and we will try to import these data stores into our system so that we will have a connectivity to the source data stores. So once we have these data stores, what we need to do is right click, and if you have a doubt in the name of the table, so you just vaguely remember that this could be the table name, or if the functional owner tells that search for the all relevant orders table, and on that you have to select these tables which has these many fields. So in that case, if the name is not proper, you click on search, then select the data store on which you want to search. So this is the source data store. The object type that you are searching is a table. So select the table, and that is external data. It is not an internal data. Internal data is something like the data that is present within the BOD system. So the data that is coming from a separate server is an external data, and you can search, give these criteria like name contains or name equal to. We always go for contain because we want to get the maximum searches. Okay, I'm giving the name as order, and I will just click on search. So it gives you a message saying that this may take long time, and press OK. So click on OK. So now it says all these are the tables that are present in my source system with the name orders. So order, I'm searching for the term ORDER, order, and I have got one table, orders. So select the table, right click, and you want to see the table structure, click on open. It will open the table structure and it will display all the number of fields, the data types and their lengths. Just to confirm if that is the right table, or if you are confirmed that that is the right table, select the table, right click. So if you even see on the data store, so there are no tables. So select the table, right click and click on import. And once it is imported, you can see the orders table within your local repository data store designer. I mean, within your data services designer, under the local object library, under the data stores tab, under your source data store, you can see the orders table. So this is one way of searching the tables. So you can select all the tables and import them. So those tables will be reflected. So this means you are copying the metadata of the table into the BODS system. So that is what I'm mentioning here, extracting the metadata. So initially when you search for a table and import that table into the BODS system, you just import the table structure and just copy the structure and put it on the BODS system. The second way of importing the table is select the data store, right click and go for import by name. So now you already know the name properly. So order details. So this is the name that I know for the source table. So if the functional owner clearly specifies the names, so you can import by name and click on OK. So it says that that name is not available. So let me go to the database to check. So order details is the table name. I'm copying the table name from here and click on OK. Now since the name is correct, it imported the table. And once the table is here, you can open the table to see the table structure. Alright. And the second one is you can re-import the table. So sometimes why do we get an option to re-import the table from the source? Any guess? So we might get a situation that the database owner updated the table structure and he says like now the table is added with 2 more fields. So please re-import the table structure so that you can see those 2 extra fields from the BODS designer. So that is the scenario where we will be doing a re-import, because without re-importing, even though there are 10 columns added to the database table, extra columns are added to the database table, we will not be in a position to see that. So if you just re-import, it re-imports the structure from which data store, the database and all these things it will give you. You just need to click on yes to confirm and it re-imports the structure. And after that you get an option to see the data as well. So when you click on the data, it shows the data from the database table, but remember this data is not present in the BODS system. So when you click on the view data option, it sends a request to the database and the database sends the data in sets of thousands so that you can see the only 1000 records in the first frame. Okay. So this is how we import the data. Now let us go and see the scenarios like what were prescribed for today. First one is SQL to SQL extraction. So let us create a job. Go for a new job and job, call this job name as job underscore SQL underscore SQL underscore ext. So we are trying to do an SQL to SQL extraction in this job. So create a workflow and call this as WF underscore SQL underscore ext. So first one we are trying to do is a workflow within which we are trying to do an extraction. So now create a data flow and call this as df underscore orders underscore ext, and the second data flow is df underscore ext. So the second one is order details underscore ext and the first one is orders underscore ext. Now one more thing, it is not mandatory that for each and every table you have to use a a separate data flow. It is not mandatory. It is just the best practice. So you can have both the tables within your one data flow, and you can do an extraction, one-to-one extraction to the target table. You can do that. There is no limitation on that. And it is always a best practice that, once you do that, what will happen is the data from these two tables get into that particular cache memory, and it overdumps the cache memory. Just in case, if you have huge volume of data, what it will do is the entire data from these two tables jumps into the system cache memory, and it tries to get calculated or executed within the cache memory. So if the RAM is good, it is okay, but if there is a limited RAM on your system, probably that will cause a performance hit. And to tune the performance, it is always recommended that have a one table per data flow if you are trying to do an extraction, or just in case if you are trying to join two different tables, that is a different scenario. You can have the two different tables and propose a join condition on top of them. But if you are using one-to-one extraction, use separate data flows, because we define the order of execution this way. So first this has to be executed, then this has to be executed. That is the reason why we are giving the connectors. So once the job gets executed, then it goes to the workflow, then it goes to the first data flow, then it goes to the second data flow. So this is the order of execution. So go to the orders ext data flow. We dragged and dropped the orders details. So let us take the orders table here, because first one is related to orders. So drag and drop the orders, and now see, you get an option here, like you can make it as a source and make it as a target as well, because these tables that are in the dark blue color here, okay, just let me highlight that. The tables that are present here are called the permanent tables, and permanent tables are like something like you write a create statement on the database table and create a table, and that will be a temporary table. So at the time of execution or anything, you can drop and recreate the table. But once you hit a commit statement on a table, that table becomes a permanent table on your database. So what we need to do is, like, these permanent tables, just remember, these permanent tables cannot be dropped and recreated at the time of job execution. So the template tables will be dropped and recreated at the time of execution. So if you want to delete the data in the permanent table before you load, there is an option. Once it is the target table, you can do that. So I'll show that to you. If you are making a table as a target table and there is already data in that, and you want to delete the data, you go to the options tab, and you have a checkbox here saying that delete the data before loading. So we will be looking in all these details a little later, so not to confuse you in the beginning. So now let me make this as the orders table, and since this is a permanent table, you get an option to make it as source or target. I make it as a source table, and next one is I create a target table. I call it as target underscore orders, and I save it in the target data store. Now if you see, I see two data stores available, because it gives you all the list of data stores, and make sure that you are saving it in the target data store. Now you can do one-to-one connect in the database tables as well, but just in case if your source table is having some extra fields and you don't want those fields, just remove this connectivity, add a query transformation. So you have a query transformation on the right hand side tool palette, a shortcut tool palette that is available here. Now click on the query transformation, click back on the designer window, connect it with your source and target tables. Okay, so now on the schema in, you see all the fields of your source table. So you select what are the fields that you need to be a part of your target table and drag and drop them as a group, or you can drag and drop them individually, or if you feel that ship postal code should be present, or ship name should be present under ship wire. So drag and drop that column onto the right hand side, and it will give you these options. Remap the column with data type, insert above the column, insert below the column, or cancel. So I feel that it should be below Shipwire, so I give on insert below. So if you do a direct one-to-one mapping, so if orders is there, you drag and drop it on top of orders. It will ask you either to do a remapping, so you are mapping the source with the target structure, or remap with data type. So just in case, if I change the data type of the target, so it remaps with the source data types. And you can insert on top of that, you can insert below that, now you can do a cancel. So we will look at more details just as of now. We'll look at all the remaining details when we are learning about the query transformation. So to filter out the fields that we don't need to be a part of your target table, you use query transformation and drag whatever the fields that you need. And you can also define the order of this output table structure. So now done, save, you have the save icon on the left top, save all. So click on the save and click on OK. Now validate all, validate the job, and you should get a message saying that no errors found. Just in case if you get some warnings when you are validating, it is okay, but if it is an error, then you have to keep in mind that you have to rectify the error, and without rectifying the error, the job will not execute. So now I'm trying to execute the job. Select the job, right click and execute. But our job is incomplete, I guess. I just added this orders table. I did not add the order detail table. So now go to the next data flow, select the orders detail table, make it as your source, and select the target data store. And here we'll do it one-to-one because you know that there are very limited fields in this one. So now save the job once again, execute the job. And now if you see, the first table is pushing 830 records into the target orders, and order detail is pushing 2155 records. The time taken for 830 records is 0.031 seconds, and time taken for 2155 records is 0.06 seconds. So it is not less than a half second you are able to migrate 2000 records. So that is the fast of this tool. Okay, so if you look at the trace of the job, so first the job is started by this particular user, and this is the port number on which the job got executed. Well, once the job is started, it starts the workflow because that is how we define the order. So once the workflow is done, then it goes to the orders underscore ext data flow, and once it gets into the data flow is started, it checks for the cache memory on your system, and it checks the available bytes of the memory, and once it is done, it utilizes the memory and it starts doing the calculations or doing an extraction from the source and dump it into the target table. And once the data is loaded into the target orders, the execution is completed, and now it goes to the next data flow. The process is completed, and then it goes to the next data flow here. Again, it searches for the cache memory, and it utilizes the cache memory, and the data flow is completed successfully. Now the workflow is completed successfully, and then the job is completed successfully. And this is the trace, and this is the monitor, and in monitor you will be seeing how many records are extracted and what is the time frame that is taken for the extraction. So I am repeating these things in a very slow manner again and again, just to make sure that you guys remember these things, because these are the things that you'll be going to see in the near future when you start working with the BODS projects. Every day you have to see this screen, you have to identify where your job is running and what are the different reasons why your job is getting delayed, and what are the different things that we can do to improve the performance of the job. So here today we have seen one of the performance tuning concept, like per data flow, have a table. Do not have more than one table because it will kill the performance of your jobs. So if you have two tables and two tables has one table, let us assume has 100 million records and the second table has 200 million records, and when you are trying to extract 300 million records will just dump into your cache memory, and the BODS system will go mad. It cannot handle such huge data. I mean, it can handle, but you have to make sure that it goes in this one by one order so that the system has the ability to handle that. Or if you don't do that in a proper way, it will just get delayed and the job runs for a pretty longer time, or it might run unendingly. So now we have seen this scenario where we have extracted the data from SQL to SQL. So the scenario is like first, or you can call it as database to database, rather than calling it as SQL to SQL. You can call it as database to database. For example, if the customer is present in SQL Server 2005, he wants to upgrade to the Oracle database, then probably he can use the BODS between that, and you can do a transfer between the database to database using the BODS. And the next, okay, we have a question coming up here. Can we have a query between two sources and one target? Yeah, we can do that. It's just the same. You drag, okay, right, make it as a source, connect that, and in the where clause you need to propose the join condition between the two tables. So here the order ID is the table, or the primary key of the one table, and order ID is the foreign key of the another table. So you propose a join between the two tables and add a query transformation. And in this query transformation, you choose what are the fields that are required. So we'll be looking at them in the rear classes Bishop. So in the next concept. So once you are familiar with the basics, like how do we extract the data from source and put it into the target, and what are the different possibilities that can be done, then we will see how we can play around with different tables and joining conditions and all those things, and load the data from two different tables and put it into one target table. So is my answer clear, Rishabh? All right, welcome. So now we'll be looking at these complex operations a little later. So now we'll look at the basic fundamentals, so that I want to feel that the tool is pretty easy and we are comfortable with the tool. The second scenario that we'll be looking at is SQL to flat file extraction, or a database to flat file extraction, when we will get such scenarios. Okay, so now I give you a real-time example for this. So I've worked with one of the client in Dubai, and that is one of the major shopping malls in Dubai. So they have the data, and they have the data spread across two different systems, which is Microsoft Navision, and the second one is BAN, and they want to migrate to Oracle RMS system. So they don't want to go for any SAP or something, they want to go for an Oracle system. And what they want to do is they want us to extract the data from both Microsoft Navision and BAN system and load it into the Oracle system. But the Oracle programmers, or the database administrator on the Oracle side, he wants to do a cross-check on the data before loading the data into the Oracle system. So he asked us to provide a flat file as an output rather than providing a database table. So we can directly load into the Oracle system, but what he wants to do is he wants us to generate a flat file as an output, and using his program he will take that flat file as an input and load it into the target system after performing certain checks. So that is one good reason why we will be generating the data from a SQL database table or a database table and generating it as an output as a flat file. So I create a job for that, job underscore SQL underscore FF underscore EXT. So this is a SQL to flat file extraction. I create a data flow, df underscore SQL underscore FF underscore EXT. Alright, so now let us select the orders table and make it as source. Now, to create a flat file, there are two different ways. One is go to the flat files of your formats of your local object library, or I repeat it this way, go to your local object library, go to the formats tab, go to the file formats, right click and go for a new. Okay, so give this as ff underscore trgt underscore orders. So remember, when you're defining a flat file, you need to remember if that is a source flat file or a target flat file. So we are trying to create a target flat file here, and that is the name. So just copy the name and give the file name here as .txt, and just select the path where you want to save it. I want to save it on my desktop, so I select the desktop and click on OK. And now it says overwrite the schema. Yeah, because it, but why it is overwriting the schema? Okay, because it is already present on that desktop. So, sorry, forget that. So I'll try to, because I think that file name is already present on the desktop, so that is the reason why it is trying to overwrite abcd.txt. Alright, so now, yeah, that's the reason, probably because the file name is already present, and that is the reason why it is trying to overwrite the existing structure. So I gave the name as abcd.txt because there is no file with the name abcd.txt. So let's put it in a more decent way, ff underscore okay, I am giving it as ff underscore orders underscore morning dot txt, and you have to specify what is the delimiter. Is that a tab, semicolon, or comma? So let us take a tab delimiter, and the column is a Windows new line because you are working on the a notepad, and you select skip the row headers as no, as write the row headers as yes, and click on save, and your file is created. So drag and drop the file into the designer, and it will ask you whether to make it as a file source or as a target. So make it as your target because we are trying to create a target file here, okay, and connect it directly with your this one. So now save. Okay, now you see there are different fields on the source structure, but you don't have any fields on the target structure. This is an improper way of creating a flat file as an output, but still it creates this one. So execute the job, and it should create a new flat file on the desktop. The job successfully completed, and if you see, 830 records are created, and this is the flat file that is created, ff underscore orders underscore morning. The data is present in it, well and good, but let us do something a little different. So when you are defining the target table structure, okay, so in terms of flat files, so what we will do is we'll delete this, we will add a query transformation. So you can do it that way as well. This is not wrong. You create a new file format, make it as a target, and connect it to your source table and directly execute the job. It will create, but let us follow some best practices. Okay, let us just do a little outstanding training, because once you do these things, then you'll probably know the difference, like what others are doing and what we are doing. So drag all the columns to the schema out on which you want to create an output structure. Select the query, right click, and go for create a file format. Okay, this also creates a file format, but the difference is now your file format has the structure on which you are creating the output table with all the data types and length. Earlier you saw only field 1 and field 2 are there, so there is no proper this thing. So now give the name as ff underscore morning underscore orders. I copy the same name and give it here, .txt, and save it on my desktop. Okay, and it is a tab separated one, and we'll go for the Windows new line, and skip the row header as no and write the row header as yes. So this headers are also present. So proper structure of the data is available. Save and close, and once you click on the back window, so you can see that morning orders is present here, drag and drop it, make it as target. And if you open the structure, you have the structure available here. But the earlier one, this one, target orders, or yeah, if you make it as target and if you click on open, you don't have the target structure, but still you have the data visible because we already executed that job. So to have a proper load structure, load file with a proper load structure, if you want to generate that, you can do it this way. Validate the job and execute the job. Alright, so the job is completed successfully. Go to your desktop, a new file is created, and open this. So it looks just the same, but the thing is that this is more proper way of doing a flat file as an output. So that is one more scenario where we will be doing a flat file to database to flat file extraction. And the next one is a flat file to flat file extraction. So why do we need something like this? Because already the source is a flat file, and why do we need to create another flat file on top of that? Yeah, the reason is BODS allows you to create some transformations within the job so that you can do some changes on the data, or you can apply some business rules on the data. So keep in mind, BODS gives you a facility to apply some business rules on the data. So if you have some data in the form of a source flat file, and you want to apply some business rules or validation checks or some cross checks on the data, so you can utilize them as a source file within your BODS and extract the data, apply the transformations, and load them into the target table. So target flat file. So okay, we will see one scenario as such now. So I have customers.txt as my source. So let me add that customers as my source table. Right. Go to the BODS system, go to the local object library, and under the formats, select the file formats, right click and go for new. So give the name as ff underscore source underscore customers, and select the path. Path is on the desktop. We have a folder called source flat files. Right, this is the folder where I have this flat file. Now click on the next folder icon to see the customers.txt. Click on open, and now the moment you specify a source flat file with a structure, it is asking us to override the schema. Schema means the existing structure here. It will override. Click on yes, and now it has the data, but it is not able to identify that in a proper way. So skip the row headers, no, make it as yes. Keep it as no, and write the row headers, make it as yes, and it will override the schema. And now all the names are copied into one particular thing because the delimiter is different. We have a separate delimiter here, but the delimiter is different. So I'm selecting the tab delimiter, click on OK, and even that is not available. So the pipeline is the delimiter that we have here. Okay. So click on this one. Now you see the data in the right format. So you can have any sort of delimiter. You can have a comma, you can have a tab, you can have a pipeline. So I have a pipeline as a delimiter. And now click on save and close. Your source is available. Now create a job. We call this as job underscore ff underscore ff underscore ext. And create a data flow. Call it as df underscore ff underscore ff underscore ext. Right, so now source customers, make it as your source file and use your query transformation between this one. Okay, so now let us assume that there is a scenario that if your phone number is empty, you have to replace that with 1234 because when you are loading some data into the target system using your flat file, the target system cannot allow null values into that. So just in case if you have a phone number as a null, it has to be replaced as 1, 2, 3, 4. So that is one simple business logic that we have. So for that, we will be writing a condition here. Go to the map tab, okay, under the local object, under the query transformation, under the mapping tab, write a statement saying that decode if this phone number is null, then replace that with 1, 2, 3, 4, 5, and if it is not null, get the phone number directly. Okay, this is a simple decode statement. We can write this: decode if the phone number is null, replace that with 1, 2, 3, 4, 5, and if the phone number is not null, if it is null, you have to do this. If not, you have to get this phone number directly from the source. So if there is any error with the syntax, so you get a cross mark here on the column, but there is no cross mark. It has a double arrow which says that this particular column is being populated with a new value. Can we create the data flow on job flow without the workflows? Yeah, we can create. So that is what I am saying. The immediate thing that we can create after a job is a data flow. So data flow is the least level. So I will share the hierarchy with you as well. What are the different things that we can do? First is the job. Job has a script. Script has conditionals. Conditional has workflows, and workflows will have data flows. But you can directly create a data flow under the job. Okay, so if you have a rule on a particular column, and if a column is being populated with some business rule, you can see a double arrow here. And now I have to create one more flat file as an output. So go to the query transformation, right click, go and create a file format, ff_trgt_ customers. So select the file where you want to save it. So I want to save it on the desktop, and give the file name. So now you have to give a new file name here, .txt, and it is a tab separated, and okay, you wrote the headers as well. Now click on save and close. Go back. Your target customer is available. Make it as your target. Connect it. Validate the job. Now you are loading a data from a flat file into a flat file, but we are trying to do some changes on the data with using the BUDS system. So execute the job. Look at the monitor. 91 records are moved into the target table. So we have the target table created. Where exactly? 1 second. Target customers, edit. It's on the desktop, and save and close. Right. I think there is one more file with the same name. Okay. Now you see where is that? One second. Okay. Yes. Let me delete this one and create a new one. I think I'm not able to trace where it is created. So if you delete any file which is being used in the job, you get a cross mark here. So let us just do it with some stupid name like ABCD, because I have already used all the file format names, and ff_ABCD, and let me save it on the desktop and give the name as ff_ABCD. Probably I have to delete all those existing files on the desktop so that we can create a new file. Okay, write the row headers as yes, keep the row headers as no. Save and close. Go back. ff_abcd should be created on your desktop at least now. If not, I have to restart the system because I haven't restarted it for quite a long time. Execute, you can execute the job from here as well. Click on execute. Yes, save the job. Click on OK. And execution is successfully completed. Now you have flat file ff_abcd and here is the data. So you can open that with an Excel sheet to see the data in the right way. Alright, so you just select this one and click and you see the data in the right structure, tabular format. Okay, so that's it. We are almost at the verge of 8 o'clock, so I have to rush for office. So what we'll do is tomorrow we will see connecting to the SAP system, extracting the data, and how the data is residing in the SAP. So we'll look at more on SAP database. ECC day system extractions tomorrow, and we will also see how do we use condition scripts and global variables within the job, and if there is still time we will look at the central repository concepts tomorrow. So any questions on today's task? Like first I want to make it very clear to you guys, like how do we do the extractions, how do we establish a connection, and what are the different scenarios that we might be extracting the data from. So why do we need something like a flat file to flat file extraction? Because earlier it might be a question for all of us saying that, okay, I have a flat file and why I need to extract the data back to the flat file once again. But now we have an answer for that because of some business rules to be applied on the data. So database to database extractions, database to flat file to flat file extraction, and database to database extraction, and flat file to database extraction we have seen. Now those are the most possible scenarios that we'll be working with database and a flat file. And tomorrow we'll be looking at how do you extract the data from an SAP system and load that back into a database table in a flat file. And any questions on today's scenarios, please ask me, or you can mail me at vivo.dataservices@gmail.com. So I will send it to everyone in chat. So it is vivo@gmail.com. Okay, you can send your queries to this particular ID if you have any. So I think if there are no questions, any questions before we call it a day? I think we are good. So if you have any questions, please send me an email to the ID that I have just pinged on the chat. So I think yes, we